everyone. I'm SP Sadashri from the Department of AI, Artificial Intelligence and Data Science. Today I'm going to present my experiment on implementation of hidden Markov models or HMM. The main objective of these experiments are to understand the concept and working principle of hidden Markov models, to calculate the probability of an observed sequence using forward algorithm to find the most likely sequence of hidden states for the given set of observations, and finally to implement this model in Python using NumPy for matrix operations. A hidden Markov model represents systems where internal states are hidden, but we can observe outputs that depend on them. The transitions between hidden states are governed by the transition matrix, and each hidden state produces observations according to the emission probabilities. This approach allows us to model sequential or time-based data, which is very useful in pattern recognition, speech processing, bioinformatics, and natural language processing. Components of HMM are modeled as hidden states, sunny and rainy. The weather conditions cannot directly observe. Observable states, happy and sad, the moods we can see. Transition matrix defines how likely we are to move from one weather condition to another. Emission matrix defines how likely each mood is given the weather. Initial probabilities represent whether the model stands. Now let us see about the algorithm overview. The steps are simple. We first define our transition, emission and initial matrix and the observed sequence. Then we create the alpha matrix to apply the forward algorithm, which computes probabilities across time. By summing the last rows of alpha, we get the overall probabilities of the observation sequence. Finally, we identify the most likely sequence of hidden states by choosing the state with the higher probability at each time step. In Python, we start by importing NumPy and defining the matrix. The transition matrix is 0.7, 0.3, 0.4, and 0.6. The emission matrix is zero point 0.1, zero point 0.9, zero point 0.8, and zero point 0.2. Initial probabilities are zero point 0.5 for each stage, and our observed sequence is 111001, representing moods over 6 days. We initialize an alpha matrix of 0. The first row is computed using initial and emission probabilities. Then for each time steps, we use the previous alpha values and the transition probabilities to update the next row. Finally, the sum of the last row is given the probability of the observed sequence. After calculating alpha, we compare probabilities for sunny and rainy at each step. Whichever is higher becomes more likely weather state. This gives us a sequence like sunny, 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 and rainy, rainy, sunny, showing how weather changes according to the observed mood. When we run the program, the output shows the probability of the observed sequence 0.00872. Most likely weather sequence sunny, 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 rainy, rainy, sunny. This indicates our model successfully predicts the most probable hidden weather pattern based on observed mood data. A hidden Markov model was successfully implemented in Python to determine hidden states from observed data. Applications include speech recognition, natural language processing, bioinformatics, weather forecasting, and financial prediction tools. In conclusion, this experiment demonstrates how probabilistic model like HMM can uncover hidden patterns in sequential data, making them essential tool in artificial intelligence. Thank you.